Schedule 3 Transportation. Problem. In this transportation problem, we are going to first solve the transportation problem to find out the initial basic feasible solution. Let us define initial basic feasible solution. To find out initial basic feasible solution, we have four methods. First one is stepping stone method, that is northwest corner rule. Stepping stone method, it is also called as northwest corner rule. Second one is row minimum method. Third one is column minimum method. Minimum method. Third one is matrix minimum method. Minimum method. Last one is Vogel's approximation method. We are going to first solve about the northwest corner method. First method is northwest corner method. Example: Dr. S.D. Sharma book. Warehouse, factory, W1, W2, W3, W4 indicate warehouses. 3 factories, F1, F2, F3, and the warehouse requirement is warehouse requirement (19, 70, 40, 30, 38, 50, 40, 70, 10, 60, 20. And warehouse requirements are 5, 8, 7, 14, 7, 9, 18, 7, 9, 18 available. If you add all these three and all four horizontally, we must also get 34. Then only it will be balanced transportation problem. First condition we have to check this, whether it will be 34 in both vertical and horizontal. And next, draw again the same table. One, two, three, four. W1, W2, W3, W4 available. 7, 9, 18. 5, 8, 7, 14 will become 34. F4, F1, F2, F3. Again write 19, 70, 40, 30, 30, 8, 50, 40, 70, 10, 60, 20. In northwest corner, first we have to start from the north of the table, north corner of the table, that is 19. 19 cell we have to allocate minimum requirements available in warehouses and in factories. So minimum warehouse available in W1 and F1 is 5 and the availability is 7. So in these two, 7 and 5 is the minimum. So first we have to allocate 5 to the 19 cell and it will become 0, and here you will get remainder 2. And again come to the next one, because we have another 2 remaining, so we have to solve this row of the so we have to come to 30 again and allocate. Here we have 2 availability and we have 8 requirements, so 2 is the minimum, so you have to allocate 2 first and it will become 0, and here you will get the remainder of 6. So then again we have to solve this column vertically. So below this one, here again 130 is there, and here we have a 6 availability and 9. So 6 is the minimum one, so allocate 6 to 30 and you will get 0 remainder, and here you will get 3 remainder, and again here we have 3 remainder. So we have to solve this second row. So do and allocate 40 to the, here we have 7 and 3, so 3 is the minimum, we have to allocate 3 to the 40th cell and you will get 4, and here you will get 0. So again here you have 4 is the remainder, so you have to solve again this vertical column first, until vertical column becomes 0 remember. So allocate 4, here you will get 0 and here you will get 14 remainder. So last one cell is this one, allocate this one as 14 because here you have 14, here also 14, so there is no problem. 14 here you will get 0 and here it is 0. So like this way we are going to solve the northwest corner view, or it is also called as stepping stone method because it is solved step by step. It looks like that. So it is called as stepping stone method. So if you add all of these values, you will get the cost of 5 into 19 plus 3 into 30 plus 6 into 30 plus 3 into 40 plus 4 into 70 plus 14 into 20, 14 into 20. So totally you will get rupees of 1015 is the answer. Is the transportation cost. And next one is row minimum method. I will take same problem as an example and solve through row minimum method. Second one, row minimum method. I will row minimum method. I will take same problem, W1, W2, W3, W4, F1, F3. Here in this one, in row minimum method, you are going to concentrate on mainly on the rows which have the minimum values. So it is solved through the row minimum method. Here 19, 30, 50, 10, 70, 30, 40, 60, 40, 80, 70, 20. Here availabilities are 5, 8, 7, 7, and here you have the availabilities of 7, 9, 18. So first in this row we have, in this cell you have the minimum value 19 and 10. 10 is the most minimum. So first allocate 7 to the here you have 14. First allocate, here you have 7 and 14. So which one you have minimum 7. So allocate 7 first and it will become 0, and here it will become 7, and this row is completed. And again go to the factory 2 and factory 3 rows. Here you have which one is the minimum, 30 and 40. So in 30 you have to allocate. So here you have 8 and here you have 9. So allocate 8 to the 30. 8. Here 1 is the availability. And again here 40 is the minimum. So allocate 1 to the 40. Here you will get 0. Here you will get 6. And this row completes. And last one is the F3 row. Here you have 40 itself, 80, 70, 20. So here 20 is the minimum. Here you have 18 and here you have 7. So allocate 7 first. Here you will get 11. remainder. Here it will become 0, and again which is the minimum one in this row? 40. So here you will allocate, here you will have 5 and here 11. So allocate 5, which is the minimum. Here you will get 11 minus 5 means you will get 6 remainder. Again in this 2, 70 is the minimum. Here you have 6 remainder, here also 6. So 6. So total of the row minimum method, you will get the transportation cost is given by Z is equal to 7 into 10 plus 8 into 30 plus 1 into 40 plus 5 into 40 plus 6 into 70 plus 7 into 20 is equal to, you will get 3110 is the cost of the row minimum method transportation cost. Third one is column minimum method. It is similar to row minimum method. It is row minimum method. It is similar to row minimum method. Fourth one is lowest cost entry method or matrix minima method. Matrix minima method. In this matrix minima method, I will take same problem as an example and solve it through matrix minima method. (19) 30, 50, 10, 70, 30, 40, 60, 40, 8, 70, 20, 7, 9, 18 is the availability, and here requirements are 5, 8, 7, 14. In this low cost entry method or matrix minima method, look at overall table of the overall matrix of the problem and try to concentrate on the values which have the most minimum value, minimum cell in this table. Here you have most minimum is 8. So first allocate values to the 8 cell. That is, here you have 8 is the availability and in this row you have 18. So which one is the minimum? 8. So allocate 8 first. and here you will get 0, and this whole complete column will vanish, and remaining minimum in these 3 columns we have 10 is the minimum cell minimum. So here you have availability 7, here 14, so minimum is 7. Allocate 7 to the 10, allocate 7 to the 10, 0. Here you will get remainder of 7, and in this complete row will be, and you have 2 columns, 2 rows and 3 columns. In this minimum is 20. So here you have 7 is availability, here you have actually 10, here we allocated 8, so it will have 10 is the remainder, here 10 and here 7, so 7 is the minimum, allocate 7, and here you will get 3 is the remainder, so here 7 will go, so this will become complete 0. So here we have 70, 40, 70, 40. Here which one is the minimum? Here is a 40, here is again 40. Here you have availability 9, 7, 5. So I will allocate 5 because it has the most minimum requirement. Here 3. So allocate 3 to the 40 because 3 is the minimum as compared to 5. So you will get remainder here 2. So here it will become remainder 0. This whole row will vanish. And again we have here another one, 40 is the minimum. So here we have availability 7, here 9, allocate 7 to the 40, here 0, here we will get 2 is the remainder, and last cell is 70. Here is the available are 4 and here requirements is 2, so allocate 2, and this both will become 0. This is how we solve lowest cost entry method for matrix minimum method. In matrix minimum method we will see complete structure of the table, and in this table we try to find out in each column and row which one is having the minimum cell entry, minimum cell values. We have to find out that minimum cell values and try to allocate first, whether it may be in first row, second row, first column, second column, anywhere. We have to find out the minimum value and try to allocate that minimum value first. And for this one you will get the total transportation cost of Z is equal to 2 into 70 plus 3 into 40 plus 8 into 8 plus 8 into 40. First solve bracket terms and afterwards add it, and 7 into 10 plus 7 into 20 is equal to, we will get 814 is the total transportation cost. This cost is less by 201 rupees as compared to the cost obtained by the northwest corner road. In northwest corner road, we got 1015 rupees. So it is less by 201 rupees as compared to northwest corner method. And the last one we are going to solve is fifth method, that is Vogel's approximation method, or it is also called as a unit cost penalty method. It is the most important method when it is asked in the examination. It is fifth one, Vogel's approximation method. Unit cost penalty method. It is quite confusing, but if you understand properly, it is most easiest problem to solve. The problem I will take same as first example: W1, W2, W3, W4, F1, F2, F3. Here available and requirements. The requirements are 5, 8, 7, 14, 14, here 7, 9, 18. In each and every method you have to check whether this is a balanced structure or not, or balanced matrix format or not. You should get, when you add vertical values and horizontal values, you will get 34. So then only it will be a balanced problem. Then you can solve it and proceed for the next step. Otherwise you have to make it balanced and try to solve it. This is the first rule to check the solving the transportation problem in each method, whether it may be row minimum method, column minimum method, or Vogel's approximation method, or not just formally. The matrix should be, or table should be balanced unit. Here you will write penalty, and here also you will write penalty. Okay. Locate the cell values, cell numbers: 19, 70, 40, 30, 30, 8, 50, 40, 70, 10, 60, 20. When solving Vogel's approximation method or unit init cost penalty method, we have to find out the penalties first in both column and row wise. So how we are going to find out the penalties for each rows and each columns is by taking two minimum values and subtract those two minimum values. Here in this row we have, first row we have 10 is the minimum and again another one is 19. We have to subtract 19 minus 10, you will get penalty of 9. And second row 70, 30, 40, 60. In this row 30 and 40 are the minimum, so subtract 40 minus 30, you will get 10. And third row 48, 70, 20. In this 8 is the minimum, another one is 20, so subtract 20 minus 8, you will get 12. In row wise we have find out the penalties for 3 rows, and again follow the same method to the columns. 19, 70, 40, 19 is the minimum and again 40 is the second minimum. Here you will get 40 minus 19, you will get 21 is the value. 30, 38 means take any one 30 and subtract to 8, you will get 22. And here you have in third column 50, 40, 70. Subtract 50 minus 40, you will get 10. And again in fourth column 10, 60, 20. 20 minus 10, 10. So finally we find out both penalties for row wise and column wise. And next step is try to look at the penalties in both column and row wise, which has the highest penalty. In column wise 9, 10, 12. Here 10, 10, 22, 20. So in column wise you have 22 is the highest penalty. So try to allocate try to solve this penalty first, because it is having the highest penalty. So you have to consider first which one is having the highest penalty value. So 22 is the highest penalty. So we have to try to solve this second column first. Here you have the requirements are 8. In this 8 is the minimum lowest value. So try to allocate first 8 to. Here you have 8 and here you have 18 will be available. So which one is the minimum? 18 or 8? 8. It will become 0. It will become 10. So this complete column will go. And next we have W1, W2, W3, W4. Again we have to find out the penalties. Now you have first column, third column and fourth column and 3 rows. You have to find out again penalties for each step. For first we are going to find out the penalties for the factory 1, that is row, first row. 19, 50, 10. Again you have 10 and 19 is the minimum values. So try to subtract 19 minus 10. Again you will get 9. Write it here. 70, 40, 60. 40 is the minimum and second minimum is 60. So 40 minus 60, 60 minus 40 is 20. So write it here. And again in third row 40, 70, 20. 40 and 20 are the minimum. So 20 is the minimum. 40 minus 20, 20. So here you will get 20 is the penalty, and again go and solve in what column wise. 19 minus 40, again 21 is the penalty, and W2 you can't solve because already we have solved this one, so it will become 0. In 50, 40, 70, here you will get again 10 is the penalty, and 10, 60, 20 minus 10, 10. So these are the second penalties. Now we are going to consider these second penalties, not the first penalties. Only 9, 20, 20, 10, 10, 21. Look at both column and row penalties and try to find out which one is having the highest penalty, and try to solve that one first. 21, 10, 10. Here we have 9, 20, 20. So among all these, 21 is the highest penalty, which is in column wise. So try to solve this 21 penalty first. So for this 21 penalty, the requirements are available at 5, and minimum cell is 19. So try to solve that one first. For 19, here we have 7 is the availability, and 5 is the requirement. So which one is the having minimum? 5. So try to allocate 5 to the 19, and here you will get 0, and here you will get the remainder of 2. So this W1 column will completed, and again you have W3 and W4, and F1, F2, F3. So again go and solve, try to solve penalties again. This is the third penalty we are going to solve. 50 minus 10, 40. 40 minus 60 minus 40, 20. 70 minus 20, 50. 50, 40, 70. Column wise 10. 10, 60, 20, 10. Look at the third penalties and try to find which one is having the highest penalty, and solve that one first, whether it may be in column wise or it may be in row wise. 40, 20, 50, 10, 10, 10. So among all these, 50 is the highest penalty, which is in the row wise located, that is in the third row. So try to solve third row first. So in this third row, W3, W4 columns are there. So in this 70, 20, 20 is the minimum cell. So try to allocate first. Here you have the availability of 10, and here you are available requirements of 14. So minimum is 10. Allocate the 10 to the 20. Here you will get the remainder of 4. So here it will become 0. So this W3 F3 row completes. So remaining are 50, 40, 10, 60. So again go and find out the penalties again. 50 minus 40, 10. 10, 60 minus 10, 50. Here again 50 minus 10, 40. 40 minus 60 minus 40, 20. So look at the penalties again. 40, 20, 50, 50. 50, sorry, 10. So 50 is the highest penalty. Solve this one. Solve this one, because here you have 4. Still 4 requirements are there. Here 10 is the minimum. Allocate. Here you have the 2 availability and 4 hour employment. Which one is the minimum? 4 or 2? 2. So allocate 2 to the 10. So you will get 0. Here you will have the remainder of 2. So this F1 row will completed, and remaining are only these 2. minimum is 40. Here available requirements are 7, here 9. So allocate 7 to the 40, it will become 0. Here 2 is available because 9 minus 7, 2. Here 2 is the availability, is the 2 year requirement. So last one is 60 is there left. So allocate 2 to the 60, you will get 0, and this one also 0. So this one is the Vogel's approximation method, how to solve. So if you reframe the solved table with allocated cells, it will look like this: W1, W2, W3, W4, F1, F2, F3. I will change the color. The allocated cell will look, after solving all the problem, you have to draw again the table and frame the structure properly. The allocated cells are 5, 19, 2, 10, 2, 60, 10, 20, 7, 40, 8, 8. Here 5, 8, 7, 40, 7, 9, 18. The total cost of the term is total cost of Vogel's method. You will get five into 19, 8 into 8, 7 into 40, 2 into 10, 2 into 60, 10 into 20. The total transportation cost will be 779. These are the 5 methods which are used to find out the initial basic feasible solution. First one is the